Hello students and welcome once again to my channel Elevate Learning with Santosh sir. Today we will be studying SSC grade 10 algebra linear equation in two variables and this is the part 4. If you wish to join my online tutoring sessions you can click the link given in the description box. Also my contact number is mentioned there so you can connect with me. In this module we will be learning about the equations which are reducible to linear equations in two variables. It is also very important to see all the previous modules before watching this one because understanding this module is possible only when you know how to solve linear equation in two variables. The link for all the previous modules will be provided in the description box. You can go through it. So now let us begin this one. Equations reducible to linear equations in two variables. Children, sometimes there are equations which have two variables. For example, 3 upon x minus 4 upon y is equal to 8. It has two variables x and y, but it is not a linear equation in two variables because the power of the variable x and the variable y is negative 1 over here. As per the rules, the power of x and y should be 1, but over here, as x and y are present in the denominator, their powers is not 1. I can write it as 3x raised to minus 1 minus 4y raised to minus 1 is equal to 8. Because of this, it is not a linear equation in two variables. Same way, over here, we have two variables, but it is not a linear equation in two variable. Same way for this example and same way for this example. Now the thing is, we can have variety of questions like this which are not linear equation in two variables. In the start, when we observe them, they don't look like linear equation in two variables. In the beginning, when I observe all these equations, they don't look like linear equation in two variables, but we can do some substitution in these equations and make them look like linear equations in two variables, and then we can solve them. Let's take the same equations and do some substitutions so that they look like linear equation in two variables. Let's take the first example, 3 upon x minus 4 upon y is equal to 8. What if I substitute 1 upon x as m and 1 upon y as n? So in the place of 1 upon x, we will have m, and in the place of 1 upon y, we will have n. So 3 upon x minus 4 upon y is equal to 8 will become 3m minus 4n is equal to 8. Now observe the power of the variables over here. Both m and n have the power 1. So this is a linear equation in two variables. Let's take the next example that we had over here. In this case, we can substitute 1 upon x minus 1 as m and 1 upon y minus 2 as n. So we will get 6m plus 3n is equal to 0. Now this is looking like a linear equation in two variables. What about the third one? Can you think of what can we substitute over here? We can substitute 1 upon 2x plus 1 as m and 1 upon y plus 2 as n, and we can get it as 7m plus 13n is equal to 0. Let's take the fourth one. Can you think of substitution over here? Yes, we can take 1 upon x plus y as m and 1 upon x minus y as n to get it as 14m plus 3n is equal to 5. So this is how we can do some substitution and convert some equations to linear equation in two variables. Now once you know how to convert them, you have to solve it. As you have already learned how to solve linear equation in two variables, only this part was new in this module. Once you substitute and make it linear equation in two variable, you can easily solve it by using any of the methods that we have learned in the previous three videos. They are elimination, graphical, or Cramer's rule. Let's solve some problems. We are starting with practice set 1.4 and this is the first question. 2 upon x minus 3 upon y is equal to 15 and 8 upon x plus 5 upon y is equal to 77. Now, what can we do? These equations are not linear equation in two variables. So here we will have to do some substitution. If we see 1 upon x, 1 upon y, 1 upon x and 1 upon y is present in both the equations. So what we can do over here is we can substitute 1 upon x as m and 1 upon y as n. So these equations will become 2m minus 3n is equal to 15 and 8m plus 5n is equal to 77. Now these two equations are looking like linear equation in two variables. Now you can use any appropriate method to solve and get the values of m and n. We are going with the elimination method. For that, first equation will be multiplied by 5 and second equation will be multiplied by 3. When we do that, the coefficients of n will become same. So we will get 10m minus 15n is equal to 75 and 24m plus 15n is equal to 231. So we have plus 15n when we have minus 15n. Now what we can do, we can simply add these two equations to get the value of m. So we will take the equation 3 and 4, we will add them. What will happen? Minus 15n and plus 15n will get cancelled. We will get 34m is equal to 306 and we will get m is equal to 9. Using this value of m as 9, we can find the value of n. By substituting in any of the equation 1 or 2, we can get the value of n. So we are using m is equal to 9 in the first equation over here. So let's use it. This is the first equation. In the place of m, we will put 9 and then we will solve ahead to get the value of n. We get the value of n as 1. Now we have the value of m and we have the value of n. But the question has asked us to find the values of x and y. So how to relate m and n with x and y? In the beginning, we had considered that 1 upon x is m and 1 upon y is n. This relation will help us now. We know that 1 upon x is m and 1 upon y is n. It means that 1 upon x is 9 and 1 upon y is 1. On simplifying this ahead, we can get the value of x as 1 upon 9 and y as 1. Let's proceed to the next question. Here, 10 upon x plus y plus 2 upon x minus y is equal to 4 and 15 upon x plus y minus 5 upon x minus y is equal to minus 2. Over here, we see that 1 upon x plus y and 1 upon x minus y is present in both the equations. So what we can do the substitution like 1 upon x plus y is m and 1 upon x minus y is n. Once we do this, the equations would look like linear equations in two variables. We have 10m plus 2n is equal to 4 and 15m minus 5n is equal to minus 2. We can now follow any one of the method that we have learned in the previous modules to solve it, but it is always better to go with elimination method because the problem gets solved quickly. So now in order to eliminate, I need to make the coefficients of any one of the variables same, either of m or of n. Let's see. We are multiplying equation 1 by 5 and equation 2 by 2. So 2 times 5 will give us 10 and 5 times 2 will also give us 10. So this time also we are trying to equate the coefficient of n. So on doing this, we will get plus 10n in the equation 3 and minus 10n in the equation 4. Now what we can do, we can simply add these two equations. Plus 10n minus 10n will get cancelled and we will get the value of m as 1 upon 5. Using this value of m in the equation 1, we can get the value of n. So n comes out to be 1. Now we have m and we have n. Now we will use the relation that we used in the beginning. As 1 upon x plus y is m and 1 upon x minus y is n, we can say that 1 upon x plus y is equal to 1 upon 5 and 1 upon x minus y is equal to 1. On simplifying this, we will get two equations, that is x plus y is equal to 5 and x minus y is equal to 1. Now we can solve these two equations simultaneously to get the values of x and y. We see that plus y is present in the equation 5 and minus y is present in the equation 6. We can simply add these two equations. In this condition, plus y and minus y will get cancelled. We will get 2x is equal to 6, which follows x is equal to 3. Now using this value of x in the equation 5, you can use it in any of the equation which contains x and y. So you can use it here or you can use it here. We are using it in the equation 5. So we will get the value of y as 2. So the final answer is x is equal to 3 and y is equal to 2. Let's take up the next question. Here 27 upon x minus 2 plus 31 upon y plus 3 is equal to 85, and 31 upon x minus 2 plus 27 upon y plus 3 is equal to 89. We can see that x minus 2 and y plus 3 are present in both the equations in the denominator. So what we can do here, we can substitute 1 upon x minus 2 as m and 1 upon y plus 3 as n. We will get 27m plus 31n is equal to 85 and 31m plus 27n is equal to 89. There is one more thing to observe over here. If you see the two equations, the coefficients are exchanged. So do you remember which method we used when the coefficients are exchanged? We did this in module 1. The method in general, it is not a method given in the textbook, but I call it as ASA method because first we add, then we subtract, and then we add to get the answer in such situation. So now let us add the equation 1 and 2. We will get 58m plus 58n is equal to 174. We can divide throughout by 58 and we can get m plus n is equal to 3 as a simple equation. So first part adding is done. Now we will go to the next part, that is subtraction. Now let us subtract the equation 1 from 2. So once we subtract, we will get 4m minus 4n is equal to 4. We can divide throughout by 4 and we can get m minus n is equal to 1. Now we got two simple equations over here, equation 3 and equation 4. Now we go to the last step, that is adding. So we will add the equation 3 and 4 now to get the values of m and n. In this case, n will get cancelled. We will get 2m is equal to 4, which will give us m is equal to 2. Now using this value of m in the equation 3, we can get the value of n as 1. So we got the value of n as 1. Now we know that 1 upon x minus 2 is m and 1 upon y plus 3 is n. So let us use it to get the values of x and y. So on simplifying, you get the values of x and y. So x becomes 5 upon 2 and y is minus 2. Let's take up the next question. Here 1 upon 3x plus y plus 1 upon 3x minus y is equal to 3 upon 4, and 1 upon 2 bracket 3x plus y minus 1 upon 2 bracket 3x minus y is equal to minus 1 upon 8. In this question, I think new textbook has positive 1 upon 8, but never mind. If we know the method, we can solve it for different numbers. So over here, we see that the denominator has common things 3x plus y, 3x minus y, 3x plus y and 3x minus y. So what we can do over here is we can substitute 1 upon 3x plus y as m and 1 upon 3x minus y as n. So we will get the two equations like this. Still, they are not simple. I have fractions. So it is best to get rid of these fractions. So what we can do to the equation 1 in order to get rid of this denominator 4? We can easily multiply this equation by 4. If we multiply throughout by 4, this denominator will get cancelled. And let's look at the equation 2 now. If we multiply the whole equation by 8, then all the denominators will get cancelled. So let us do this. So we multiply the equation 1 by 4 and equation 2 by 8. So we get 4m plus 4n is equal to 4 into 3 upon 4. Here 4 gets cancelled. And for the second equation, we are multiplying throughout by 8. So 2 ones are, 2 fours are, 2 ones are, 2 fours are, 8 ones are, 8 ones are. So we can see that all the denominators are getting cancelled. And on simplification, we will get our two equations as 4m plus 4n is equal to 3 and 4m minus 4n is equal to minus 1. If you observe this, we have plus 4n and minus 4n in the two equations. So what we can do, we can simply add them up so that plus 4n and minus 4n gets cancelled. We get 8m is equal to 2 and we get m is equal to 1 upon 4. Let's use this value of m in the equation 3. If we use this in equation 3, we will get the value of n, and n turns out to be 1 upon 2. Now, let us go back to the first substitution. We know that 1 upon 3x plus y is m and 1 upon 3x minus y is n. So let us put the values of m and n over here. So we will get 1 upon 3x plus y is equal to 1 upon 4 and 1 upon 3x minus y is equal to 1 upon 2. Now we can change the side. We can simplify to get two equations. We get 3x plus y is equal to 4 as the fifth equation and 3x minus y is equal to 2 as the sixth equation. Once again, we have plus y and minus y in these two equations. We can simply add them up. So the y get cancelled. We get the value of x as 1. Using this value of x in the fifth equation, we can get the value of y. That also turns out to be 1. So the solution is x is equal to 1 and y is equal to 1. Remember, if the question is positive 1 upon 8, the answer will be different, but the method will be same. The answer will be different, but method will be same. So be careful, look at your textbook and accordingly you can solve. With this, we end up the practice at 1.4. I hope you have understood this method of solving simultaneous linear equations. This is called substitution method. If you understand everything, you can like this video and share it with your friends. I will be uploading new videos on your topics of State Board 10 standard. So if you don't want to miss any new topic or any new video, you subscribe to my channel and press the bell icon. In the next session, we will be learning about the word problems based on linear equations in two variables. If you wish to join my online tutoring sessions, you can fill the form given in the description box, or you can contact me on my number given in the description box. So in the next session, we will study about the word problems. Till then, take care. Thank you.